Okay, so I just want to quickly go over the first part of this, which is to create a sort of spawnable grid blueprint. So if we create a new blueprint in here, blueprint class, we're going to create an actor-based blueprint. We're going to call it grid spawn. Let's call it grid test. And if we open up the editor for that, it's on the wrong page, of course. So what we're going to do is we're going to spawn a bunch of meshes in a for loop. So if we go to the event graph, we're going to do it on begin play. And the idea here is pretty simple. What we're really interested in doing is just setting up a scene so that we can see how fast this thing renders, right? So we're going to render the stock cube mesh a number of times. What we probably want to do is we want to add it as a sort of child of this object, just so that it's a little bit easier to understand. So, I mean, I've got an example here, right? And if I run it, you'll see that it spawns kind of children of this thing. So, what we're really going to do is we're going to spawn a static mesh and set it on this particular actor. So what we need to do is we need to have a for loop. So we need some variables. So let's add some variables now. Let's call this one xdim. We'll make that an integer. And if we compile it and give it a default value of, I suppose, 1. And then make it public with the little eyedropper, and then we duplicate that for y dim. So we want x dimension and y dimension. We want a float value as well. Let's just make sure we set that to 1 as well. Oh, yeah, we have done. If we create a new variable, set it as type float, and that's the, we'll set it as spacing. Hope I've got type, doesn't it? Spacing. And that's the distance between objects, right? So if we're going to create it on a regular grid, we want a value that's going to be regular. So if we, we're going to use the stock cube, and that's like 100 millimeters, sorry, 100 centimeters wide, basically 1 meter. So if we set this to 100 by default, we should get what we want. So we've got the X dimension, we've got the Y dimension. We should probably set, we can set a scale value. So let's do that. And call that scale. And we'll just set that to 1 by default. So compile and set it to 1. We might want to, have different types of parameters for these things. So one last thing we want to do is we'll want to do something in the for loop, and I'll just sort of add that here. We want to set the y value. Now we're not going to make that public. It's an integer again. We're not going to make that public. We're just going to use it as a variable. So what we really want to do is we want to do a for loop here. So there's a bunch of different types of for loops, right? So we want a for loop where we've got an index, a start index and a stop index, right? So that's probably the one we want. And what we're going to do is we're going to have a nested for loop, right? So ultimately we want to have an outer for loop, which is maybe the columns or the rows. I mean, it depends which way you want to do it. You can either do it row wise or column wise. So the first for loop is kind of is one dimension of the grid, right? The rows or the columns, and then we want to take the same node again. So Control C, Control V, and we want to call another for loop. So let's say that this is our y dimension, right? So if we go from 0 to our y dimension, so if we just drag our y dimension to here, that's going to be our y loop. And then we can do the same thing here, but with our x value. So what we're going to do is we're going to say So what happens is that each iteration of a for loop, we get the index, which is the like output of what the current value of the for loop is. So in this case, we actually want to use that. So we want to set our y value, and it's useful to do that now. So let's just drag that in there. I like having sort of all my nodes lined up. So let's just move these guys out of the way while we're here. So what we've got is the setup of the for loop, right? So basically, we're going to loop over our y dimension, and we're going to call this other for loop, and we're going to remember which y value it is. We need to remember the y value so that we can do the actual calculation of where the objects should be spawned. So inside this for loop, we need the x dimension, because we're going to sort of do a loop over the x. And we want to actually create the meshes, right? So the thing we do from the loop body here is we call the add static mesh component. So add static mesh component essentially what it's taking is, well, we are going to do manual attachment because we don't really want it attached to the parent. We're going to do some of that stuff ourselves. So we can add a component, right? So the component's basically going to go in this list of components here, but it's not actually going to have a mesh. So what we'll need to do is first thing we need to do is feed it a reference to self. So if you type in self, you'll get a reference to self. So we need it to sort of pass in what it is that's going to add the static mesh to. So it's going to add it to this. So self is the object. Now you'll see here it says relative transform. Now relative transform in the blueprint editor, when you've got things like transforms, right, you can do this, right click it and go split struct pin. And sometimes that's really useful to sort of, especially if you only want to set specific properties. So in this case, we're going to make a uniform scale. So let's get the scale value, and we're just going to feed it into, well, we want to feed it into all of these elements, right? So we can split the struct pin again and just feed the scale into all of them. So basically that gives us a uniform scale value if we never need it. We're not going to do any rotation, so we'll leave that blank as it is. And we're going to split this struct pin because we actually want to move the cubes depending on where they are. So how are we going to move the cubes? Well, first off, we need to get actor location. So get the actor location for this current actor, right? But we only want some features of that actor's value. We don't really want to copy all of it. So what we probably need to do is we need to, again, split this struct pin so that we can access the individual values. And what we're after doing is calculating for each one of these indices a different value, right? So if we drag off the X value, and we're going to need to add some value to it, right? Because, we're adding another float to it so that we're calculating the X coordinate. So basically this is the index, is the sort of which kind of index in the for loop it is, which version iteration through the for loop it is. So we need to get this value and we need to multiply it by a float, and that float is the spacing, right? So basically we want to sort of space it in the X dimension. We want to space it across. So if we're going to do the X loop, we want to space it across in the X, right? So We take that spacing, we can feed that into the transforms X. That's relatively simple. Now what we want to do is we want to get the Y component. So remember we've set the Y value here already, right? So we can actually do the same kind of thing that we've done here. So we can take the component output for our position in the Y. Well, let's just hook up the Z to make sure we've got that one done. So the next one we need to do is we need to multiply that one again by the spacing. So we need to get the Y value. Let's just say, so get the current Y, multiply it by the spacing. So again, spacing, and then we're just going to add that onto our current actor location's Y value and stick that in the final output. So basically get the parent's kind of location and for each Y offset it by a amount of spacing based on the Y index of that particular loop. So essentially that should give us the final position for the X and Y values. And now we just want to essentially set the mesh information. So if we come here and call set static mesh, so actually if we can just come up here and go set static mesh, and the mesh we want is cube. Let's go for engine basic shapes cube. So you know, you might have you probably should have a cube in the engine pretty much all the time, cube and sphere. If you don't, obviously you can use another mesh, but ultimately we would probably want to parameterize this, right? So we can like pass different meshes to spawn in the grid. So final thing, we want to attach that mesh to our self, I guess. So we've got our default scene route, right? So we can get that default scene route, and we want to attach component to component. So our parent is this default scene route, and we want the thing that's being returned from this. So that will be this guy here, right? So we're essentially attaching the output of this. So this attached component to a component thing just means that, like, when you spawn a component object, it attaches to its parent properly. So it's kind of, because we said we're going to do a manual attachment, we need to do this attach part. It means that we can change the rules for like how things are attached. So for instance, let's keep world positions for all of these things. It just means that it, instead of sort of relative to itself, it's relative to the world kind of thing. Okay, so that should give us all we need for this. Let's just test it out. So if we drag one of these guys into the world and set its dimensions, I'm just going to delete this guy because we don't need it for now. And set its dimensions, let's say 2 by 2. We know that the cube is 100 in scale, so let's just run that, and we get actually 3 by 3, but that's because we've got, like, we already set it as 0 to start off with. So if we want a 2x2 grid, we can do that. The one thing that you should notice here is that, like, if we set it to 10, you'll notice that that doesn't work anymore, right? Because we actually have to set it to 10 here and then run it. So that's one problem. Another problem is that we maybe want to, instead of indexing from 0, maybe we want to index from 1. It depends really, because our value of 1 in here kind of makes sense from a design point of view. So we maybe want to, if we index from 1, that means we'll get the correct number of objects. So if we then, obviously, if we set it to 1 and 1, we should just get 1 cube, right? So that makes a little bit more sense. And if we do 10, we should get 10 in a line. Okay, so that, I mean, that's the basic idea of setting up this particular grid, right? We just want to basically do the 2 for loop, the nested for loop thing. So have a go at doing that, and then we'll go on to the next part, which is to create a construction script and start making an instant static mesh out of it.